Okay, so what questions do you have for me? Man. Yes. Which one? 3E? All right, let's look at 3E, guys. Guys, shh. Stop, please. Thank you. Okay, so we're going to one from the right. Okay, now I know what happens. You guys panic when you see that. Don't even look at that till you look at what would happen if that wasn't there. Okay? So, I want to stand there. Okay. So, ignore that for a minute. Just stick in the 1 and then see what happens next. Okay? So what happens when you put in the 1? You get what? 1 over 0, which falls into the category of non-zero over 0, correct? As soon as that happens, you know that the answer to this limit is one of three things. It's either infinity, negative infinity, or does not exist. Okay. All right, so here's what you're going to do. Now is where you worry about that. Okay? So the fact that you're coming in from the right means, for example, you might be putting in something real close to 1, like maybe 1.01. And again, don't go reaching for your calculators. You're not going to be able to use a calculator on this. Just imagine putting in 1.01 there, 1.01 there, and 1.01 there. I think you can just look at that and see whether this whole thing will be positive, negative, or does not exist. Which one is it? It'll be what? When you stick in 1.01 there, 1.01 there, 1.01 there, is this whole thing positive or negative? Positive. So guess what the answer is? Positive infinity. It's that simple. Got it? You don't. Do this and then I'll know you know what you're doing. Show me this at least. Got it? Yes.
If we did it like that, when would we know it does exist?
The only way it would be does not exist is, first of all, if that wasn't there, then you have to check from the right and the left. And suppose one was positive and one was negative, right? Then the B does not exist. Or suppose this was a radical function where when you plugged in the number, you got undefined, like a negative inside a radical, that would be does not exist as well. But if you get a positive number, it's positive infinity. If you get a negative number, it's negative infinity. Right? Okay, what else? What else? What else? 1B. Okay, let's look at 1B. Okay, before you start 1B, I would take this problem and I would rewrite it as this. Because that's what it means when we put the exponent between the trig function and the angle. Isn't this what it really means? The whole thing's being raised to that power? So looking at it like that, this is a composition. So if you're going to take the derivative of a composition, you must use the chain rule starting with the outside. So, does everybody agree that's the derivative of the outside? Yes? Bring down the exponent, subtract 1. And then what are you supposed to do next? Well, you're supposed to put the inside back in the way it was and then continue taking the derivative of the inside. So going inside, what's the derivative of sine? Cosine. And then don't forget to put its inside back in. And then you got to finish the chain rule by taking the derivative of the inside, which is what? Yeah, what's the derivative of 3 minus x? Negative 1. Okay, so then this is probably how I'd write the final answer. Does that make sense, guys? Yes or no? Okay? It's just the chain rule. It just so happened that you had two inside functions. You have to keep going inside and taking the derivative until you were done. Does that make sense? Okay, what else? What else? Keep them coming. Keep them coming. Which one? 4? Everyone know the difference between instantaneous rate of change and average rate of change? What's instantaneous rate of change? Just the value of the derivative when you plug in the x value. That's no big deal. What's average rate of change? Change in y over change in x. It's just slope from algebra 1, isn't it? So for 4b, you would just do f of 3 minus f of 0 all over 3 minus 0. Correct? Yes? Okay. Did anyone get to Number 5. Basically, I would just do the derivative test using tables. Yes? Okay, I would probably do them separately. So for A, B, and C, you can make one table, right? Doing the first derivative test table, right? And then for D and E, you're going to need to make a table using where the second derivative is 0 or undefined, and then go from there, right? Does that make sense? Okay, now I know it starts to get tricky when you get to number 6. So is anybody there yet? Yes? I'm sorry? 6E. Okay, let's look at 6E. Look what just happened. My pen got stuck on my wedding ring. Oh. Just got some blue ink on it. Okay. Okay, so 6E you said? All right, so here, first of all, let's look at number 6 from the beginning, which is this. This is the position function for a moving object, right? Yes? And you know that what? X of 0, 0. Whether you need that right now, I don't know. But for E, it says to locate V of 1 on the graph of V. So I'm going to need to graph V. So let's start with that. Ready? So I would not try and find the derivative by hand. If I give you a calculator, let the calculator do the work. Okay, so here it goes. Ready? So by putting this in, and again, make sure you're in radian mode, guys, by the way. Okay, by doing this, and then here if I put, whoops, n deriv. Whoa, I don't want that. Okay, but I really don't want to graph it yet. I didn't mean to graph it yet. Sorry about that. All right, so forget that graph for a minute. Let's go back to y equals. Okay, what I meant to do is go to here and hit alpha window so I can put in n deriv, right? And then x there, y1 here, and then x here. So what that'll do is it'll graph the derivative, right, which is the mixed up. So I'm going to turn the position function off. So that way when I graph it here in a second, I'm only looking at the graph of y2, which will be my velocity. Does everybody agree that y2 is the graph of my velocity function? Yes? Okay, so let's do that. Again, I'm going to start, first of all, I'm going to check my mode. Okay, I'm in radian mode. Then I'm going to hit zoom Z trig for my starting window since there's a trig function involved. Okay, and by the way, we only want to look at the interval 0 to 1.5. So when this stops, I'm going to change the window here. You got to be patient with derivatives. Okay, they take a while to graph. And did you say it looks like a jail cell for your cooperation grade? Okay. All right. So here we go. Window, I'm going to go from 0 to 1. Wow. That was strange. It wasn't showing up. Okay, don't worry about anything right now except the x's. Okay, just change the x's and look at the graph. If it's not good enough, you can change some other things. Is that clear? Yes? Okay, so hit graph now. Okay, so you guys, when it's this close to the x-axis, I'm going to spread it out this way. How do I spread things out this way? By lowering my what? My y-min and my y-max. And actually, no, I don't even need to do that. I'm good. I'm good the way it is. Okay. And I might need a little bit more or a little bit lower y-min though, maybe -6 or something. Okay. So you can see what's happening, right? The graph looks like it starts below the x-axis, it goes above, it comes below, and then it looks like it goes above and stays above on the rest of the interval. Is that clear? Okay, so looking at the graph of the velocity, it says to locate v of 1 on the graph. How do I locate a point on the graph here? I do what? Second calc, or second trace, what? Value. And I type in a 1 and I hit enter. You see where the point is? You see where it's flashing down here? You see that point right there? 1, -4.888? Okay. All right, state, and I want to state whether the particle's velocity is increasing or decreasing at that time and whether its speed is increasing or decreasing at that time. Okay, so let's write this down. V of 1 is negative 4.885. Okay, so what does that mean? Well, the fact that since V is negative, no, I don't want to do that. The fact that V is negative just means the what? The position is what? Decreasing, right? Doesn't that mean the position is decreasing? In other words, the particle is moving backwards? Yes? Yes? Or in a downward direction? It's moving in a negative direction. Isn't that all that tells you? Okay, but that's not what they're asking here. On E, they want to know whether the particle's velocity is increasing or decreasing. So what do you think? Looking at that, you see how the velocity is going down at that point? It's going down. You see? Yes? It's on the downward part of the graph. So clearly the velocity is what? V is what? Decreasing. Isn't it? Yes? Yes or no? Okay. All right. Now, and since V is also negative, isn't V negative? It's below the x-axis. Yes? Okay, so if the velocity is decreasing and it's negative, what's happening to the speed? It's just snow falling down. So again, you guys, if the velocity is decreasing and it's negative, what's happening to the speed? Well, again, if you're not sure, let's write down an example of what that might look like. V is negative and decreasing. Aren't those negative and decreasing? But since the speed is absolute value of velocity, wouldn't this be the speeds in something like that? So the speed is actually what? So the speed is what? Increasing. Does that help, guys? Does that help? Yes or no? Okay. All right. What's that? 6D. Okay, let me back up to 6D. Okay, guys, let's look at 6D. It says, find the total distance traveled. Okay, you need to know that the distance traveled can be found how? By taking the what? Okay, taking the antiderivative of the velocity function. Yes? Taking the antiderivative of the absolute value of the velocity function from time 1 to time 2. So in this case, 6D, you're going to take this, right? Yes, there'll be 1 or 2 distance travel problems on the test. Guarantee it. Probably maybe 1 on each part. Okay, and so there it is, guys. And so all you got to do is punch that in your calculator. Do I need to do that, or can you do that? You can do that. By the way, the absolute value is where? It's under what? Math, what? Num. Number 1, ABS. So I'm not going to go through that. I think you can do that. Okay, does that help? Okay, what else? 3G. All right, let's look at 3G. Okay, when you're taking a limit as x goes to infinity or negative infinity, isn't that when you look at the degrees and the coefficients, if you need to? Yes? Okay, so the first thing you do is look at the degrees when you're taking the limit as x goes to infinity or negative infinity. Okay, and what did we say? When the bottom has a higher degree than the top, what's going to happen to the whole fraction? And well, that means the bottom is growing quicker than the numerator. And so when that happens, what happens to the whole fraction? It gets what? It gets smaller, so the limit is what? 0. Make sense? Okay, yes? 3F. Okay, let's look at 3F. Again, don't panic when you see the one-sided limit. Don't even look at that until you need to. Okay, so don't panic because of that. Ignore it for now. And what would happen when I stick a 2 there and a 2 there? I get what? 0 over 0. Okay, so that means you're going to do one of two things. Use some kind of algebraic trick to rewrite it, to get rid of the discontinuity, or maybe use the Hoppe-Tell's rule. It's your choice. So there's two ways you can finish this. Okay, you can factor. You get x, what? X squared plus 4, x squared minus 4, don't you? And by the way, x squared minus 4 can be factored further into what? X plus 2, x what? Minus 2. Okay, so once you do that, these cancel, don't they now? When you stick a 2 there and a 2 there, quickly, what do you get? I'm running out of time. What do you get? 32. So this had no effect on the limit at all, did it? Nope. Okay, the other way is the Hoppe-Tell's rule. Okay, so if you take the derivative, you get this, don't you? Yes? And then if you try substitution again by putting a 2 there, what do you get? 32 over 1, which is what? 32. So it's up to you which method you want to use to finish that. Does that make sense, guys? Yes? You feel better now about limits? Got a good handle on them now? Okay, good. Keep going again. Guys, give me a lot of time on this early in the week. See how far you can get. And don't spend too much time on one problem trying to look things up. That's not the way I want you to prepare. I'll help you if you need it. Do the ones you know how to do and leave the rest for me. Is that clear? Okay, be efficient on with your time on this.